All right, thanks all for coming. Today is the long-awaited presentation by Jason, who we didn't get it sorted out before he then went off to the US for 6 months or so, and so we were hoping to hear from him a lot earlier, but he's probably got a lot more to say now, so it's a better presentation.
We hope.
Yes, that's right. We're lifting the bar for you. Okay, anyway, if you'd just like to welcome Jason.
Thanks for that. Hello, Jason Held. I'm the Director/CEO of Saber Astronautics. We're a space operations and engineering company here in Australia, also in the US, doing software and mission control, a lot of research in artificial intelligence applications to it, reducing the barriers to entry to space. I have this sort of canned presentation. What I thought I'd do today is we'll go through it, but I'm going to be a bit off script today. And the reason why is because I've been in Australia for about 10 years now, and I've been seeing the space industry change at the same time I'm watching Australia as a nation change. And I think the conditions are really favorable to other companies starting up, kind of like what we did. And I think it's favorable to people like you. I think for people in this room, it's far more favorable for you right now than it was for us when we started. So I'm going to go through these, tell a bit of a personal story as well. And I kind of invite you guys, I don't normally do this, but I'm going to open the kimono all the way. So if you guys got any embarrassing questions, questions about things that we did wrong as well as the things that we did right.
Why isn't UNSW on your slide?
And right away, well done, because this is an old slide, and this, I got to update this because we've had a lot more traction than what you see here. And in fact, commercially, if you're running a business and you show a slide like this, which shows a whole bunch of research organizations, investors would be like, all right, well, how much business are you getting from that? They're going to scratch their heads a bit. So UNSW should be on here, ADFA should be on here, ULA should be on here, and a whole bunch of other very interesting acronyms should be on there as well. So don't worry too much about that. But look, any other embarrassing questions before I begin? Okay, so we only have one guy who's really going to listen to the instructions. All right, so look, to talk about why I started Saber Astronautics, you really got to talk about why I got into the space industry in the first place. And this really goes back to when I was a kid growing up. People would come in and be like, all right, little Jason, what do you want to be when you grow up? And yeah, it's kind of a tough question when you're a younger kid. And the older I got, the more serious the question got. You get to be 14, and it's like, what are you gonna be when you grow up? Oh, yeah, you got to think about it because you're entering undergrad. Then you get into undergrad, you go through a 4-year program. By the end of it, you got to start thinking of jobs and career and start mapping out your career path. What are you going to be when you grow up? And this question gets more serious as time goes on. And I ended up coming to Australia to do a PhD. And at the end of my PhD, even as an adult, as an older student, you come back to that same sort of question. What are you going to be when you grow up? It feels exactly the same as when you're 5. And the answer I have in the back of my head it hasn't really changed. I just want to be a Jedi. Is that so much to ask? If you think about it, being a Jedi is cool. You have a lightsaber and you're fighting the forces of evil in a spaceship. And of course, it has actually changed for me. I'm no longer 5 years old. I now want to be Mace Windu. He's just a bit cooler. Luke whined a bit too much when he was a younger kid, so I don't really relate to that. But yeah, that same sort of passion, motivation, push humanity into space. The sort of things you don't normally tell an investor or a business contact that would usually scare them off a bit. But this holds for me as well, and it holds for the people that we tend to attract at Saber. These are people who think, all right, it's not the Mars Society, the National Space Society, and it's not an advocacy group. We're doing this as a business. We're doing this serious. We want hardware in space. You got to do these sorts of practical things as well to kind of reach those sorts of dreams. And for me, my path to space was a little bit odd, actually, because I had very poor grades in high school. In fact, another one of those embarrassing things you don't tell people, right? You think like we're going to get a degree and then get a job, and then next thing you know, you're on the moon drinking a beer. Truth is, yeah, I had very poor grades. I wasn't going to go into the astronaut corps right away, right? In fact, my academic advisor said, don't bother applying for colleges. Apply to get into a TAFE, and maybe you could kind of make it, right? But I did manage to get into a very good military school in the United States, good education, joined the Army, and actually did competitive fencing, hence the name Saber and Saber Astronautics. If you've ever wondered why we called it that, that's where it comes from. And had a lot of fun, so I was in the Army in Korea, and I managed to get a weekend pass. It's not easy to do in Korea, you know, because you're right by the border. And I went down to Osan Air Force Base, and off a whim got a flight lesson for my first Cessna flight. And the guy who was running the class was a Black Hawk pilot, so he didn't mess around a whole lot. He was like, "Here, get in the plane. Here's how you turn it on. Okay, here's how you fly." And I'm sitting there holding the old shit handle. Okay, and here's how you turn, and here's how you land, and I'm holding the other side of the old. And then, okay, now we're going to do it again. This time you try. Okay, so yeah, you push the throttle in, up you go, you fly around, you land, and it kind of brought back all those passions I had as a kid. I was like, okay, why am I messing around with all this stuff? Space is what I've always wanted to do. And you can do it even if your grades as an undergrad or weren't that good, or as a high schooler weren't that good. So let's just go for it, you know, kind of live your passion. So I went to my battalion commander and I said, Colonel Coles was his name. I'll never forget this. You know, Army commanders they're not really dreamers. They're very much practical doers. Right? I was like, yeah, sir, I want to transfer to Space Command because that's the natural thing, you know, for me to have to do. He goes, Space Command. This is the Army. You're in the ground force. It's kind of, excuse me. You didn't actually talk like that. So obviously he said no, so I resigned, and I moved to Colorado. I was 26 years old when I started my engineering career. Got a job doing biomedical. I moved to Colorado because it's one of the largest space economies in the United States. You know, and you walk everywhere, you got Boeing, Ball, Lockheed, all these really cool companies. And I started doing computer programming, and then after a year, got my first job working on test design for the International Space Station. And once you have that on your CV, the other companies kind of pass you around like a joint, and you're having a great time, and that's the start of a really good space career, right? So I was doing that for a while, and September 11th happened. And I got pulled back into the Army against my will. But since I had all these experiences, they said, okay, you're a space guy, come to Space Command, and had a lot of fun doing that. It was actually the best time I ever had in the military, was working with Space Command. So yeah, at this point, you know, you've got a career. I was doing my master's in space at the University of Colorado, and I thought I'd go for the astronaut corps again, and I actually made it pretty far. I did okay. I was one of the selectees that the Army sent up to the actual national packet, but you know, you didn't get in. So I didn't get in because I didn't have a PhD. I didn't have an advanced degree. You know, just halfway through your master's isn't enough for these guys. So I applied to different places, got to Sydney Uni. So I came here to finish my master's, ended up with a PhD and a wife. And now, all right, 10 years later, I've actually spent more of my adult life in Australia than anywhere else in the world. It's really interesting. So, you know, you get to the end of an experience like that, and you get these experiences that you didn't expect to have when you were a younger kid, and the motivation's still there. So I was looking at the conditions that are there in space in the United States and here, and with all the different friends that I made along this way, called them up at the end of my PhD and I said, let's start a company. And the company, again, Saber Astronautics, because a couple of the guys, you know, we all kind of did fencing together as well as some of the other stuff. So you know, if you've seen our presentations before, you know we've got a lot of technical punch that we add to whatever we do. We got, you know, engineers who worked on Hubble and the ISS. We actually poached half of the flight software team from the Wide Field Camera 3 for Hubble. Yeah, initially, we were based in Colorado. We started off initially in Colorado, and the first job that we had was we were going to make the first space-rated microchip for Sun Microsystems, which would have been massive. They would have competed against AMD, and it would have been great for them. 6 weeks later, the global financial crisis happens. Sun gets bought out by Oracle. The job went away, and Saber USA became very quiet. So what are we going to do next? Well, I'm here in Australia, and I'm looking around. I'm like, you know what? There's certain strategic advantages that Australia has that the U.S. doesn't, and it's all under operations. So if you're going to launch a spacecraft in the United States, you've got to talk to it on the dark side of the planet. So we decided to form a sister company, and that's a different partnering, but we all kind of work together. So if you look at our company as a whole, we got that really good mix of real hardcore engineering, space expertise, operational expertise, PhD academics, and experienced entrepreneurs, right? So ties in with the type of skill sets we have. Our strategic vision is exactly that. We want to take space operations and we want to apply real hardcore R&D to modernize it, to make it easy enough for your high school kids to use. I'm sick and tired of people having to get a PhD in order to be able to do space operations. And you think about the conditions. I talk about the conditions in space these days. Obviously, I'm talking about CubeSats, right? You are able to launch, build, manufacture, start up your own spacecraft company for $150,000. I've seen it done by companies coming out of California, Silicon Valley, and all that jazz, right? And if it could be done there, it could be done here, all right? $150,000. It's the CubeSat, it's the manufacturer, customers, cash flow, that starts you up, okay? But the big problem is operations. Right? So as you could think in the back of your head, but wait a second, you know, you got all these big companies that are doing space, Lockheed, Northrop, Boeing, Ball, big names, a lot of money into it, tough competition. How are you as a startup in Australia going to do that? Well, this is what I call big R&D, right? And I've seen some nonprofits, good people doing these nonprofits, by the way. I don't want to hammer them. Good people. They get these big projects and they work for years and years and years and it never gets off the ground because they say, well, we don't have enough money. So they go to the government and say, with an empty hat, please give me some money, we'll give you all these cool things. And the government says, we're already buying those from the United States. We don't need you. That's the Australian problem in one sentence. Kind of a run-on sentence, but still a sentence, right? So we said, okay, we need smaller projects that we could bootstrap, that we could launch, that we could get off the ground and get customers and cash flow right away. How do we do that? Well, we got a couple of smaller projects. The Dragon Space Tether sits on the bottom of your satellite and it drags it back down to Earth at the end of its mission. It helps solve part of the space junk problem. And we've also got this, some of you guys have seen it, some of you might have had a few drinky poos. Vostok Four Pines Stout. We partnered with the Four Pines Brewing Company to make the first beer designed for drinking in space. So the idea is, and this is our tactical plan, we're going to start off doing stuff like this, build a brand and a reputation for doing cool stuff, and make a bit of money and put that money back into our hard R&D. And in the background, we've been working on this for about 4 years now, okay? In the foreground, especially here in Australia, this is all you hear about, okay? And now we're at this kind of a cool place where we're starting to release some of the stuff we've been doing out here. Very interesting story about that. And I got a lot of flack for the beer project from the space community here in Australia. Got a lot of flack from you guys.
From them?
Yeah.
Not from me.
Not from you, because you like your beer. 50-50. Like honestly, people they're like, okay, it's a cool project, right? And it's fun, but it's not serious. And there's this sort of thing that we as space engineers have. It's kind of, and it's not an Australian thing. I see this in the U.S. as well. There's a chip on our shoulder, and it's a serious business. So we have to do things in serious ways, and that's another thing that's changing with space tourism. It's not. Yeah, there's an aspect to it which has a tie-in for not serious, and that tie-in also directs to the general public. So you ask yourself, how do you engage with the general public and get them interested in space? I call this a STEM program for adults. Right? Why should kids have all the fun? Right, so beer is the #1 entertainment drink in human history. We've had beer since before we had the wheel. In fact, it took us about 5,000 years to sober up enough in order to invent the wheel. Okay, so that's the thing. There's always a market for it. You're going to drink it in space, but really we're going to sell it on Earth. That was the point. We need to sell this to people who actually drink beer. All right, so that was why we went to the Four Pines and said, you know, I really love your beer. Their flavors had this kind of hoppy characteristic to it, which from our backgrounds we knew would kind of cut through the challenges of drinking a spaceflight consumable in space. So we did a whole series of research. And it's interesting, the more you peel away the onion, yeah, okay, it's just a beer. But in order to drink a beer in space, you have to get the carbonation level right, because the human body, carbonation, gases and liquids, they don't like to separate very well in zero G. So you drink a carbonated beverage, and the gases, you feel like you want to burp, and the gas and the liquid comes out together. It's called a wet burp. Some of you guys on this side of the room knows what that feels like. It's very unpleasant. You don't know what I'm talking about, do you? Okay, calling you out. But anyway, so we did drop tower tests to make sure that the carbonation level was right. We did taste tests at the Four Pines to see, and this was more of a product problem. If you change the carbonation, how does that change your flavor? We had to make sure that the flavor was consistent regardless of carbonation level. And then we took it on the Vomit Comet out of Florida and flight tested it. And it looked something like this.
You're not seeing it.
Oh, shoot, you can't see it? Well, then, you know what? Then I'm not showing it to you. That sucks. Sorry about that. Let's try that again. Okay, you're not going to see it, therefore. Ah, ha, ha. All right, so you know, if you notice what he's doing, he's got something on his head. He's actually taking his skin temperature, his heart rate. There's a whole bunch of questions that we just didn't know about how the human body metabolizes alcohol in zero G. So that's the research side of things.
Why are those people pixelated out?
Why are those people what?
Pixelated out.
Because legally we could not show their faces. They asked to be removed. They didn't want their company identified with drinking beer in zero G. All right, so just to get this beer, just to do this flight, we had to. What do we have to do? We had to do all these massive things. We had to get FDA approval. We had to get approved by the TSA, like Homeland Security. It was a very long process to get all those flight approvals. The FAA had to approve it. It was the first beer ever consumed on a commercial microgravity aircraft. Okay, so you know it looks like a lot of fun, but it was quite serious. Also gave us some zero G flight experience. It was quite useful. I'm not going to go over the experiment so much. Out here in Australia, that footage that you just saw was the #1 most clicked video in Australia. To put it into context, #2 was David Letterman. And I think we had about 40 million views around the world for it. So broad international appeal. Right now we did another flight back in October. I won't worry you guys about the video just for the sake of time. If we got time afterwards, I'll show it. But one of the problems was getting the beer out from the bottom of the bottle up to the mouth so you could drink it. So essentially, we made a fuel tank for beer. We made an insert that you could stick into any container, and it wicks the beer from the bottom of the bottle up to the mouth where you can just drink it normally. And right now, we're doing the industrial design for the actual bottle itself, so you can buy it off the shelf. So that was the beer. Caught a bit of flack for that from the space guys, but you know, from the beer sales, Four Pines, because of this, is now a national distributed brand across Australia. This and the fact they got a real good sales team. So if you think about that, good product, interesting product, good sales force, you have this sort of recipe for a successful business. So the more of that you drink, the better our research looks. So go consume as much as you can. the other product that I was talking about before was the drag in space tether, and just gives you an idea of how it looks sitting on the bottom of your spacecraft. What it is, it looks like a yo-yo spool, and that was part of the design. We wanted to make it very, very simple. The idea is you unroll this spool of conductive tether. All right, and the tether is made of a material called argon. And it's significant because argon has this property where it's as conductive as copper, and you can weave it like a textile. Right? So it's really, really light, quite strong. It's a Kevlar derivative. So it had those right properties where if you fly in the spacecraft with an unrolled tether through the plasma magnetic field of the Earth and ionosphere, then the old right-hand rule where magnetic fields around your fingers, you're going to have a current going in the direction of your thumb. Now you've got an alternative source of power for your spacecraft. And also you've got a Lorentz force going in the other direction, which means you can pull the spacecraft down. Right? So if you think about some of the legalities of space and setting up a CubeSat, all the CubeSats that you see tend to be very, very low Earth orbit, shot out of the ISS, because once you do that, you're low enough that you'll crash and burn within about 90 days, 6 months on the far end. So very low risk. But there are a lot of customers that want to go higher altitude and do different types of studies, different types of business cases. So with this on board, we can guarantee that you can control their descent down to Earth and burn up rather than staying in space for 25 years, right? So that's the idea. It's really designed for CubeSats. And we had two series of flights. We're the only non-American company. This is straight from the Australian side, by the way. We're the only non-American company to make it into the NASA Flight Opportunities Program. All right. So I think the only other non-American organization was an academic group. You might have heard of them, called Oxford University. So it's quite selective. Really happy to have made it into there. And what we were doing is we were, let's see if I got this video. Let's see. They did it to me again, didn't it? All right, so let's set this back up. Duplicate. All right, so a lot of tethers have a problem where, because of the designs, they snag upon unrolling. So we had to prove that our tether would be able to release, unroll properly in 0G. And there you go, a whole bunch of static stand tests. And we actually have a flight date for this. Yeah. All right, so we actually have a flight date for this middle of next year with our customer at a Manipal Institute of Technology in India, and that was the release from their actual spacecraft. So, all right, so exciting times for that as well. So that's already on the market. If you guys are doing a CubeSat and need to use it, we're happy to sell you more. Okay. So that's the stuff we've been getting a lot of press for in Australia and talking about. Now it's time to talk about what we've been working on in the background for the last 4 years. And also kind of ties into why we're doing this. Space operations is broken. You can see the problem right there. When people talk about reducing the barriers to entry to space, they usually talk about small satellites and CubeSats and reducing the cost of the engineering. They're also talking about reducing the cost of launch. But operations actually account for up to 1/3 of the cost of your total mission. Right? You can see why. Slap a whole bunch of data on there, and it's really hard to understand what's going on, which means you have this linear relationship between the amount of data that you have and the number of people you need to manage it. Right? So, the more complex your spacecraft, the more people. And what that means is a high labor cost. There's a high training cost as well. The European Space Agency's Operations Center takes anywhere from 12 to 18 months to train up an operator. And you know how they're doing it, right? You hire on at ESA, they put you in a side room, and you do simulation work for I don't know, 12 to 18 months. And then they stick you in that chair, and you got to pass a whole bunch of tests. And you got to learn very basic things like what's going on in the spacecraft, how do you know, what effect is making a change on that spacecraft going to have on its orbit and on its behavior and the diagnostics for it? It's a tough problem, and everybody's doing it that way, right? So I want you to sit yourself in one of these seats. Imagine you're a space operator right now, and one of these little words on the screen turns red. These words represent a defect on the spacecraft that you have to manage. And you're scared right now. You're very scared right now. Your adrenaline is actually up. Because it's not just one of these words happening, it's usually a whole bunch of stuff on the screen. So you're dropping your coffee, you're saying, oh shit, you sit down, and you're trying to diagnose and find out what the errors are in that spacecraft. Because commercially, every minute of downtime is millions of dollars lost to your downstream customer. That's the B-1 Optus spacecraft that went down, what, in the 90s, and you had half of Sky TV in Australia went down, and all of New Zealand. It's a whole bunch of people, about 12 million people saying, hey, let's switch to Foxtel. Now, if you're like me and you're interested in going to Mars and the moon and stuff like that, well, then there's human life involved. I grew up, I was 14 years old, not correction, I was 15 years old when the shuttle blew up, the first one, I should say, right? If you had a way to autonomously diagnose that spacecraft, you could have saved human life, right? So it's a significant problem. Okay, so we already talked about that. All right, so imagine if you're a space operator using Piggy. That's our stuff. Instead of words on a screen, now everything's three-dimensional. Everything's graphical. You're looking at the sun, and you're looking for space weather effects, such as solar radiation storms, radio blackouts. You can see sunspots. This is data that's actually piped in from the Space Environment Center. Right? We get a live feed from them. And then you can fly around, and it's kind of hard to see because of the screen, but you got 150,000 stars in the Hipparchus catalog, right? So you can do attitude control, simulation work, and you can get day-night raycasting straight from the graphics unit of your car, so you could do thermal estimation. And let's see, what else are we going to show you? We're going to show you overpass information, so you know when your spacecraft is going to fly overhead. Here's now, and the different colors represent the different spacecraft depending on the ground stations that you have. And you can look at your magnetic field models and gravity models like you see there. We also get electron and proton data. So these are all different things that can affect your spacecraft and can cause damage to your spacecraft computing. We also have different features. If you need to do spacecraft that are looking at the ground, you could look at elevation effects. We can embed that in the system. Just depends on the type of effects that you guys are going to want. So that's all fine and good, but you really want to know what's happening inside that satellite, right? And there you go. You could open it up. You could look inside the guts. You could highlight individual subsystems. But eventually what's going to happen is components are going to start turning red. You remember that solar flare. Red means there's a defect that has to be managed. So there are other colors there that define cause and effect. So if there's a component that turns blue, then it means that it's just part of your cause and effect chain. So what that's telling you is now the operator has total control of the information they need to see. And on the back end, the artificial intelligence is telling you the information that's important for you to look at. Right? So instead of just an alert saying 50 things are broken at once, it's saying, well, 50 things are broken, but it's because of this one object over here you need to look at first. There's where you need to diagnose. So it's going to save massive amounts of time for the operator and make it very, very easy for you to use. All right? So this software that I've shown you, we just announced a few weeks ago that we're selling as an academic license, so people in this room can use it. It's going to retail for about $110 per seat per semester, but if you do the pre-sale over the next month and a half, then we'll give you $80 per seat per semester, plus anything that you guys need as far as your own requirements, we'll be embedding in the software as we go along, right? So that's something that we're doing only for Australians. We want to give you guys a jump ahead over the United States. Right, so there you go. If you think about the capability and the change, it's a paradigm shift from 2D text-based to 3D GUI. And I know it sounds kind of obvious, right? Because a lot of us here might have played video games. Raise your hand if you're a video gamer, all right? I'm really glad to see you on that. Really glad, all right? About 90% of this room, okay? That is a generation of new space engineers coming in. All right, we showed this demo to people in the US and they're salivating for it, right? And the reason why is because, again, you don't need to have a PhD to learn this. You don't need to hire somebody to train you in it. It's self-training. You just use the mouse and click and train yourself, right? If you're trying to teach people orbital mechanics, you can show them the orbit. You don't have to, you know, when I was teaching orbital mechanics at Army Space Command, I had this big table with like all these hoops on it that I have to show, right ascension of the ascending node, inclination, I had to do all these things. And people kind of got it, right? But now you can just do it in the graphics and show and it changes right away. What else? You don't need 20 people to run 2 satellites. You could use 2 people. You don't need 20 people to run 2 satellites. You can use 2 people to run 20. Is that okay? I need to get past the CAN stuff and go back to more about stories. But anyways, back end, the artificial intelligence is a bit more abstract, so work with me a bit. This is where most of our heavy R&D went into. The task is to take screens like this. This is actually a screenshot, by the way, of what space operators have to use. Right? This is what it looks like. Each item here represents something on your spacecraft. Okay? A thermal measurement, electric power measurement, etc. Take all this data, encapsulate it into performance metrics, and analyze the performance metrics for cause and effect, and then pipe that into the graphics right away. That's kind of how that's working. And we've done a bunch of demos over the last couple of years, especially since 2012 is when we had the AI stuff working properly. And we did our first demo with a research group, actually the ops team out of NASA Goddard Space Flight Center. They gave us the data for NASA ACE. ACE stands for Advanced Composition Explorer. It's a space weather satellite sitting at Lagrange point 1. And its mission is to look at all the different space weather effects that can happen. So this is actually one of the major pipelines that our species gets for space weather information, right? It's kind of important. A spacecraft is a medium complexity satellite, about 1,200 different telemetry items piped in every 16 seconds. So it's a fairly big data type of a problem. We had this process to come up with the performance metrics, and we ended up with 22 metrics relating to health and 3 metrics relating to space weather. So the idea is taking the space weather and the health together in the same model. Okay? And we run it through our artificial intelligence solution. A lot of Bayesian inferencing goes into it, a lot of mixture modeling goes into it. And the result is some chart like this where the circles represent your performance metrics, the arrows represent the connection between them. So what you're looking at is space radiation connected with thermal and electric power subsystems connected with your operational metrics and factors of performance, right? And what you want to be able to do is prove that this graph is correct. So what you do is you take the values here and you recreate the values here, right? So we took the health and welfare of the spacecraft and we recreated the electron density during one of the largest space weather events in human history. Okay, and I'm going to go a bit deeper here. You typically, when you make, you guys ever deal with artificial intelligence at all? Raise your hand if you've ever, there's maybe 2 people in the room, 3 people. All right, AI 101, the Bubba version. You ready for this? You get some data. You guys used linear regression before? That more people are shaking their hands, right? It's like linear regression. You get some data and you find an equation that fits the curve. And then what you have to prove is that that equation is still accurate when you go time forward, time and again, okay? So we trained the data off of, we trained the model off of the 2003 space weather event. Okay, it was the largest space weather event in recorded history. That's the one that blew out half of the power grid in Canada. You guys remember that? It's pretty cool. I was like, wow, you know? And then we implemented it on data from the 2011 space weather event. Okay, so that was the second largest event. And solar flares are kind of like thumbprints. No two are alike. So being able to show this level of accuracy, they're almost exactly alike, is really significant because that shows time invariance says 8 years later, and it shows that it's a general solution. Okay. All right. So along the way, we did a whole bunch of other experiments with this where we had multiple UAV. This is actually from my old PhD back in the day, so I don't talk about it much, but UAV swarms, so it could detect performance for swarms. Individual robots like rovers, so we did that as well. So we're looking at the health of the actual rotor encoders and as they degrade. We did a job with CSIRO where you had a spacecraft structure with a whole bunch of sensors on it, and we're trying to characterize impacts to the spacecraft. So if you get a soft impact or a hard impact, we're able to tell the difference fully autonomously so they could tell how to repair it. We recreate a roll, pitch, and yaw on a rocket based on atmospheric conditions. And anybody recognize this? This is a Mars base, right? Called the Flashline Mars Arctic Research Station. It's up in the high Canadian Arctic, a couple of 100 kilometers from the North Pole. So actually went up there in 2004, and from the data from that, we were able to estimate the entire logistics function. We were able to model how much food people were going to eat and predict that based on their operational plan. So if you think about it, you can just say, all right, we got 3 people on a team, they're going to go off to this part of the world, and this is what they're going to do. How much food are they going to eat? All right, so we were able to calculate that. So if you think in terms of the ISS, or back to the whole passion for Mars is kind of what happened. So another big game changer for the space operations community, autonomous diagnostics, a lot of long-term benefits there that we're exploring, and the idea is turning the Space Operations Center in Sydney into something we call the Responsive Space Operations Center. Okay, so sorry, we just a fun photo, but the idea is a lean space operations center where, because you could autonomously diagnose things, it doesn't take as much time to fix problems, and because you got the graphics there, your operations are much smoother and easier. So I had undergrad students train themselves up in space operations in a matter of, I think, days to 1 or 2 weeks at the high end for commercial customers that we're servicing out in California. So the SkyCube satellite, which is auto-connect with SkyCube, we were connecting with them, and they were flying with us out here in Australia. We're like the night watch, and their day watch were ground stations out run by the United States Navy called the MC3 network. And they benchmarked us against each other. All right, we were twice as fast of a connection. That's the connection from the satellite to us, to the customer, and 3 times as many connection attempts. So every time the satellite comes over, can you track it? Can you talk to it? Can you at least try and talk to it? Right? 3 times as fast, 3 times the connection attempts as the United States Navy. Right, so us, a little startup team out in little old Sydney. So good win for us. I just got a couple of photos of the ground station up at Sydney Uni. Not a big deal. But just to show, we did their ground station for them. We did all the hardware for them. And so we are setting up these RSOCs, Responsive Space Operations Centers, other places around the world. We're setting up one in Colorado right now. We've got the lab for it. We just need to set up the antenna for it. In 2016, we're going to have ones in California, and talking out in the UK has given us permission to set one up. Just talking through costing. And of course, one up in Resolute Bay, far north, you've got to have one to handle the polar orbits. The Colorado lab is ramping up. Anybody ever been to Boulder, Colorado? One of my favorite places on earth. This goofy looking guy over here holding the space chicken. I'm showing you this photo. His name is Adam, a good mate of mine, really good friend of mine. owns this property up in Lyons. The reason why I'm showing this property like that, that's where the space chicken lives, is that's where we're setting up the other ground station hardware. And he might look a bit dopey, but he wrote the ground station software for Hubble, so I think having him taking care of our ground station is a pretty good thing, right? So that's the Colorado. And each RSOC does its own research. So each RSOC does operations as a service, but is also tasked with doing its own research. So the City Lab does research in operations and kind of the human aspect of satellite control. The US lab is like, all right, well, you can diagnose a satellite on the ground. Let's go ahead and make some hardware and put it up into space. And we got funding for a Small Business Innovative Research Grant, about $120,000 from them, from NASA Ames, to put together that. Just looks like a little simple FPGA controller, but what you're looking at is changing its state dynamically on the fly based on multiple variable regression systems of systems, right? So if it's hot, plus it's highly radiated, plus you got other systems that are trying to do their job at once, what's the best avionics I could have that I could change to that will give the best performance, right? And here, the same kind of thing, the closer the red and the green line are together, the more accurate we are, and that's how you know that the state it switches to is the correct one. So we passed our phase 1, and we're just waiting on we're going to find out at the end of the month whether we get phase 2, so it's a pretty exciting time. And a lot of commercial companies in Colorado are looking at that now, saying, hey, maybe we want to sell that too. It'd be kind of nice. So in the interest of time, I'm not going to bore you guys too much about kind of the business aspects of this, other than to say for you guys, if you're thinking of starting your own business doing space, now's the time, right? Numbers up here, all right? So the satellite market is 171 billion, about 50 billion of that is in ops. You divide the market up, I divide it up into 3 different ways. You got the large, micro, and nano, just the mass of the satellite. It's kind of how you divide it up. The large market is a very stable, special kind of market, but the small guys is massive, massive growth right now. It's looking like the start of the IT industry was back in the 90s. You guys remember that? Maybe some of the older ones here are like, oh man, maybe I wish I was 22 and started my own website. Now I'd have $1.5 million from some investor. That's what's happening right now. I'm watching it. All right, so if you're finishing up your studies and looking to do something different afterwards, now's really the time to get into the industry. Okay, 150,000. Does that sound like a lot? It's less than half the cost of a Boost Juice franchise. Just saying. Okay, and just the cost for our operations services are here, but if you want to talk to me about something that you need, go ahead and do so later. This is more the happy sales slide. See, UNSW needs to be on here as well, doesn't it?
Yeah.
Huh?
We are.
Someday.
Is it?
Yeah, we're next to you.
Next to.
Next to you. Oh, how politically correct.
Because we're friends.
Yeah, we're all
So keep your enemies close.
Actually, we are getting closer, and I want City Uni and UNSW working closely together on projects. The Delta V Space Hub. So Saber, UNSW, City Uni, and Launchbox started a startup accelerator for space. And we're going to be training people and teams on how to build their own business doing space. Basically learning from everything I screwed up in the first couple of years I tried it out. Right? So interesting here. You got some non-space companies here, Open Spatial and Alpha Centauri Fund. What's that about? If you can diagnose a satellite, you can diagnose all these other things that we use here on Earth. So we did cash flow analysis for a company that does cash flows for ATMs, and we did water utilities for a major water utility provider. They had sensors around their neighborhood, and we're able to detect when a leak would happen and the effect that leak had on the neighborhood, on the community, on the village. Not quite sure how they're going to use that. Maybe you knock on your door, hey, can you turn your faucet off? You're disturbing the neighbors. But still, these are the kind of things that people are wanting these days. And that's the end of the formal presentation. Thanks again on behalf of Saber Astronautics, and of course, thanks from Maze Windu. hopefully you guys get some more embarrassing questions than Andrew. He was very easy on me. So what do you want to know? You got me for 10 minutes. Let's kimono wide open. What do you guys want to know? Yeah.
Given that it's like presumably at the start of your startup you weren't making any money, and
Yep.
but I presume, and you also
we were.
presumably needed to live.
Yeah.
How did you have the money to eat and have a house and stuff?
Look, a lot of different ways to tackle that. For us, fresh out of grad school too, so I was used to eating ramen noodles every day. It was the kind of thing where my wife and I sat down and I told her what I wanted to do. And I said, the only way this is going to work is if we move to the States. Because remember, 2008, different time, 2008. Nothing was happening here in 2008. I was like, there's no way we could get this going here in Australia. And she's like, I don't want to move to the States. Let's find a way to make this work. I'll tell you what, I'll get a job and I'll give you X number of years to get it off the ground on your own. And we just made that deal. Some of the other partners were doing similar things, and after a couple of years, we said, all right, look, we can't work out of the home anymore. It's not serious when you're working from home. Early research is not business. I'd have people coming over to the apartment for business. We'd be meeting at coffee shops and things like that. And yeah, it's funny. I talked to about 4 other businesses, and we were all doing different things. One guy doing a GPS tracking company, another guy doing a commercial photography company, and we were all clinically depressed. I'm serious, man. Clinically depressed. I saw a therapist once. I was like, man, I'm irritable. I'm angry all the time. I don't know what's happening. I had this great career, and now I'm just kind of working from home. And she was like, yeah, my husband did the same thing. You pay me $180 per week for this service, and we've had our first service, so why don't you try just spending it on rent for an office and stop being such a cheapskate? It is the best advice, and it's like the way to the world. You have your own space, you do it, and what happens is once you make that decision, I see a lot of teams, they start off at universities and they get spun out, and that's a double-edged sword for a variety of reasons. It can work, but you got to look out for certain things. One of which is you're not putting your own money into it. So that's what I did. I put my own money into it. I had a little bit of saved up. Sold all my stocks, so I had a bit more saved up. Started teaching fencing on the side. Seriously, literally I was teaching fencing like 3 times a week, right? And that brought enough money to pay for the rent, and food was ramen noodles and hanging with the wife, and then we started making money. We started getting what I call gap filler jobs. That's the water utilities and stuff like that. We were making about, billing ourselves out for about 15 grand for about 3 weeks worth of work. So about 5 grand a week is about, and that's actually cheap for what we were doing. It's cheap, right? So it's literally, it feels like clubbing something over the head and dragging it home, right? That's what you got to do. You really got to fight for every dollar and build a brand, right? And over time, word gets around. Oh, these guys can do that. So they were happy with what we did. They pitched us out to 3 other companies, and so we were making some of this money on the side. So, the hardest part is you don't go from 0 to Mace Windu. You go from 0 to nose coming off the ground, and we were doing that actually for a few years, and then finally, right now we're just barely in ground effect, right? Our wheels are off the ground for sure, right? The Vostok Space Beer paid off its loan to us. It's now a profitable business, making about 100 grand a year. We're just rolling it back in there because we want space flights, right? That's just how it goes. Good question, actually.
I've got 2 questions.
Yeah.
At the beginning, you sort of said that in the time here you've observed changes in the Australian environment. I just want to elaborate on that a bit.
Yep.
And you also just want to comment on what you do with interns at your place.
Oh, jeez, how can I forget about the intern program?
Oh
my God, man, that is really important. Actually, it ties into your question. How do you do all this work? Ho ho ho. Talk about the internship program first. We get 150 applicants a year. Average UAI is 99.4 of the applicants that we get in. The applicants come from Germany, France, the United States, and Australia, and India. And we take as many as we possibly can. There's so much work we have to do. We find something that fits you guys as well. We started taking interns in 2011, 2012 kind of thing. We take honors thesis students on occasion, but usually like someone I'm really comfortable working with personally, right? Because it takes a lot of my personal time. The students come in, it's an unpaid internship most of the time. They do a lot of work for us, but it's not like an internship at like Boeing, you know, or Taylor. I shouldn't call out names, because actually there's some internships out there that are really good. You're gonna work. You're gonna engineer right away, the moment your feet hit the ground. And it's gonna be good work for us. And it's gonna be good work for you, because you're gonna leave Saber, and our people have gone off to get master's degrees, PhDs. We had 2 get into Stanford, 1 into Purdue, another one into MIT. 2 of our graduates ended up working at Planet Labs, another at Johnson Space Center. You know, it's a career starter. It's a career starter. I haven't made a career starter here in Australia yet, except for 2 of our interns we've been able to hire as full-time employees. Finally hiring people. Finally, such a good feeling.
Some of them started their own business.
And 2 of them started their own business, Seb and Solange. Great point. And like for me, it's exactly what I wanted to see in Australia, right? More like, because I've been training space engineers in Australia for 10 years. Right? I founded the Space Engineering Laboratory at Sydney Uni. Myself and Alex Green, who's also a partner with me at Saber. Right? And when you do that, and then you graduate, and basically hand it off, and you see it's still operational, functional years later, it's a great feeling. So I've trained about 300 space engineers in Australia. And I've seen 75% of them leave for the United States and Europe. And the other 20% of those go off to rail core, go off to robotics, go off to non-space, but their passion's still space and they don't do it. Seb and Solange, really, man, those 2, you got to get to know them. All right, they've done a good thing, and I want to see more people do what they've done. Okay, and that ties into your first question. All right. What has changed? The biggest change has been an industry change. $150K to start up your own business, that's a Kickstarter. All right? Half of my customers are doing that. You know, they're $150K, they're starting their own business. You know? And he sold his business for $1 million, which is great. You know, so he exited, which is a nice little exit, but still an exit. Yes?
Sorry, I didn't butt in there, but that's
Please.
a really great presentation, Jason. The context is important for you, for these people, I think, in terms of career direction and stuff. But my principal interest is around the Delta V Space Hub and how that works. Is it a collaborative structure that shares data, and what sort of people are involved in that?
Well, I kind of started that show gathering UNSW, Sydney Uni, and Launchbox together, and we just started with a simple loose collaboration, saying, okay, we're going to work together, building businesses. We don't quite know how we're going to do it yet. Then we managed to find their current CEO, a guy named Tim Parsons, who had industry experience. By industry experience, I mean marketing experience with Channel 9. He's a space engineer PhD with real marketing expertise, so he's our CEO. The plan is 2 things. One is a structure where we incubate and accelerate. Incubation apparently is a bad word. Accelerate companies like CubeRider and other groups. Give them training, give them a place to sit, build a community. What we haven't decided there is whether we're going to take a piece of the pie or not. Typically with an accelerator you get like 10%, 20%. I think that's too high. I think that's the mistake the universities have made in the past. I think the universities are getting better at that slowly. So whatever, if it is a percentage, it'll be a very small one, maybe 2%. But we still have to kind of polish that up on our end. The other side is a rideshare program, which we want to use to incubate companies that don't want to go through and build their own satellite, just want to do a sensor. So CubeWriter might be a provider for that, or we might do our own. Launchbox also is doing their own rideshare type of a program. It's kind of a recent trend I'm finding internationally. US companies are doing the same sort of thing.
Okay.
So there's definitely a market for it.
Thank you.
Internet companies have done the same sort of thing with startups. They provide a platform, so that this CubeSat would be like a platform.
Yeah.
And so Delta V would provide the launch, the data down the satellite itself, and then you just come up with your experiment and get your data back. And all that space side of it.
Yeah. No embarrassing questions. Yes.
Did that 3D ground control software have a name?
PIGI, Predictive Interactive Ground Station Interface.
Okay.
Another point I probably should have mentioned in the presentation.
You probably did.
Thank you. Yep.
Did you get sick during the microgravity experiments?
No, I did okay. You actually get sick. You get the sickest in the 2G portion. In the high, you do parabola, right? So you go up and you're 0, 0, 0, 0, and then you're 2G, 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 2G. I got a little bit uncomfortable during the beer test because not for that reason. It was because, and it's funny because the person that I had with the second test, she's a real cool Aussie biomedical engineer. She was the only flight test we've had like doing squats in the 2G. She was a legend. But usually you lie flat on your back and you don't move. I had us both reduce our anti-nausea meds because you do the literature review behind the pharmaceuticals, and nobody's ever studied whether there's a drug interaction between alcohol and scopolamine and stuff like that. So we said, okay, it's probably safe. We'll reduce our dose. So she was lying down, but I was having to set up the experiment every time. And it was a lot of little pieces there, so when you're constantly moving your head in 2G, you're going to feel a little uncomfortable. So I had to kind of lie down for a minute at the end of the flight. That was it. We had one guy get sick on the Dragon flights, but look, I mean, we've had, I think Saber right now has about 780 parabolas under our belt as a company. So, you know, we're doing really good.
Back on the topic of PIGI, have you at the moment secured any purchases of student licenses with any universities at all?
Yes, we have.
Okay.
Well, it's ADFA and Sydney Uni.
Okay.
We're both doing trials.
Cool.
And waiting on you.
We're harassing you guys, all right? Right.
Rock.
When you first started your company, what were some of the mistakes that you made, and what could we do to try and avoid those mistakes?
Oh hell. The first mistake I made was doing it from home. And I said why? There's another mistake we made. We had an operating agreement which had a whole bunch of founders. What you'll find is that there's a time span between when you bring a founder on board, especially under a sweat equity where there's brand new kind of thing, and when they get bored. Because everybody has their own life, you know, and it's like some of these non-for-profits, they start up and it's like we're going to Mars, we're going to the moon, we do these things. And then, you know, you got to put food in your belly, and you got your kids you got to deal with, you got your lives in uni you got to deal with. And after about 6 months, most of our partners went silent. So again, you know, we had that contract, it was looking good. GFC happens, you lose it, everybody kind of backs away. So that was definitely a mistake. Would I do it differently? I'm not sure. Hindsight's always 20/20, because now we're in a really good position where, because we kept that structure out in the US and we have it here, we're selling stuff in the US and we're selling stuff here. We're an international company now, really flexible. So I think the lesson learned is you do the best you can with what you have. Make lemonade, you know, when things go wrong. There are other lessons learned. We formed in the U.S. as an LLC, which is kind of like a PTY Ltd here in Australia. without realizing that a lot of companies won't do business with LLCs. So we had to form another company just to, as an S corporation, just to be able to handle the business and kind of feed it back up, and it's just complex. So it just means a little more pain later on. I'm here for you guys. Anything else? Any other questions?
One question.
Yep.
And the reason I'm asking this was with our little BRE project, one of the things we were asked was, we've got they came back to me and they said, oh, we've got these things called Neptune scripts. And of course they're related to this ground control thing. And they basically wanted parameters, you know, it's red, green or orange.
Yep.
And come up with things and tell us what these limits are. And you're sort of scratching your head going, oh gosh, you know, I've got a GPS receiver here.
Yeah.
What should I make these limits? So you kind of go through and you give them some numbers.
Yeah.
Presumably you need that for some of your CubeSats as well. If
Absolutely.
you've got an onboard computer, somebody has to come up with all these things.
This is Mission Ops 101, actually. This is one of those things like Australian scene versus US scene, right? And especially Acture forming up this really good program making awesome hardware, not realizing some of the things you have to do on the ground. And this is one of those things, typically red, amber, green. Green means everything's good, amber meaning you're within a range that's uncomfortable, where you can't have things that are damaged. Red means he's tested that object, and if you're in the red, things are going to melt. Electric power is going to go the wrong way. It's going to go past your resistors, whatever. Is that your question? You want to know why? Or?
No. I want to know, presumably, you know, in order for you to do your models, you need to know what they are. But it sort of means that your models are sort of tied in with particular pieces of hardware. So do you have a different model for every piece of hardware you've got, or how does it work?
Yeah, okay. So the technical side is a really good question. And you have to define what is a model.
Yeah.
Right? So when you're talking about these 2D screens, way back, boom, there. Each one of these words can turn that color, right? Model for them means that if that temperature value is higher than an amount, that changes color.
Yeah.
That's all it means, right? They have some data-driven models, very early stages compared to what we have, which if it turns red, it's not doing cause and effect analysis. You're trying to predict when it's going to turn red and stuff like that. And they're fairly limited because it's discrete. Okay. What we do differently is it's a continuous dynamic function. Okay. But you don't get around the fact that every spacecraft needs its own model. But the way you construct that model is very different. For them, you need to know all that information for every single one of your items. For us, yeah, you need to have the red, amber, green as far as limit checking. That's normal. You always have to have limit checking. But for us, all the intelligence is going to happen without it. Okay. For us, the red, amber, green is just to help out with give a color scheme. But the actual intelligence, we don't need it. We need just the raw data. And we come up with the process of finding what the right variables are that's interesting to the operator. Okay, and then we work backwards up. So you're not really getting rid of that process. That's a process you guys should be doing anyways, because that's very important for you guys to do. Okay. Yeah. Anything else?
Yeah, when you first started, did you think about taking on investors to try and get yourself a bit of cash?
Not at first, because we knew we didn't have enough to entice people. We tried in 2010 here in Australia, and had a very friendly response, a lot of looky-loos from Tech 23 is a good conference. The problem with Australia is that back in 2010 especially, everybody was used to and comfortable with dealing with the IT industry. It's not an IT thing, they don't understand it. Nowadays I think it's quite a bit more favorable because they're watching, there's like a 5-year difference between what happens in Silicon Valley and what happens in Sydney from an investor behavior perspective, in my observation, right? And right now we're starting to see the first exits from companies that started up in Silicon Valley about 2 years ago. And the exits are ranging anywhere from 5 million, 20 million, 60 million if you're talking about Planet Labs. And even New Zealand companies, right? I mean, same kind of thing for them. they're going to Silicon Valley, getting some of that money here, and sometimes partnering up. So we're looking at that again now, just revisiting these and saying to the old investors, hey, remember us, you know, cool and kind of cute, and now we're actually selling some stuff, and we could actually do it, so we relook.
So is that your eventual plan, to be able to sell Saber off once it becomes large? Is that your exit strategy?
We have, it depends. We got two different triggers. If in about 5 years we end up making somewhere around the $10 million range, we'll exit either with an Australian IPO, or we will exit via acquisition from some of these other companies. We've identified a few companies that have already asked to buy us, right, kind of thing. But that's a very U.S. play. Right? If in 5 years we're making a lot more money, then we exit via an IPO that's a bit more international, more like a Dow Jones kind of thing. I actually believe that doing an IPO for 10 million is very dangerous. I've seen it cause problems with other companies. Yes?
Would you do a reverse takeover? Like a reverse listing?
I don't know what that means. So
like you take over, you find like a mining company that's bankrupt, you take over, you buy them out, and then you use their listing on the stock market?
I don't know, but I don't know. I've never heard of it before. It's just, you know, I run into these things where my lack of knowledge is lower, so I'll just have to learn about it. Not quite sure what the advantage would be to us right now. So just another arrow for the quiver for me to look at. So thanks for that. Yep. Is that it?
Is PEGI approachable by a third party? As in, could you say, for example, the Dawn mission that I'm looking at right now, studying Vesta and Ceres, right?
I'm not sure what you're asking.
No, I'm just so, could you study those those systems in the asteroid belt?
Yes.
Is that in the software already?
It's not in this demo that I'm showing you, but the one that we're doing for academic release is going to have all the planets. We've got all the planets in there now.
Okay.
We can put in asteroids of any kind that you request if you're a customer. It's not hard for us to put it in.
Okay.
But literally, we get the two-line element set from CelestiTrack. The only thing we don't have in there is tumble, but if you have data on the tumble, then we'll put that in there as well. And that's pretty straightforward for us to do.
Okay.
What's your long-term plan for PEGI in terms of licensing it out?
I didn't actually go over that slide, but it's here. Services on the RSOC, so we can play with it ourselves. Selling academic licenses, so we're pretty much on track with our original timeline. So the academic licenses are going to go out in a month and a half. And that's kind of leading into our alpha and beta for more enterprise type of stuff. We're actually starting the sales actions for that now. And we got 3 different licenses. Right? Academic license, a business, like a commercial license that's really designed for small businesses, right? So if you wanted to buy PEGI and use it for a commercial operations center for your own like ops team, like BlueSat or something like that would normally be like $15K, or a startup company would be $15K to do it yourselves. For someone more like a medium-sized company, guys that are already making about 10 million a year kind of thing, it would be $250K per license. Kind of fits like a video game model. We've seen that before. And then the big enterprise level would be like if we had some deal with Boeing or a national level operations center, we would have a price point somewhere in there. And we got a lot of flexibility as far as servicing options. If you want to use us as your operations center, as a CubeSat team, then SkyCube, we did, they initially signed up for, we got 3 different levels of service. Level 1, telemetry service, about $1.5K per month, right? And level 2, where you actually got someone at a seat controlling your spacecraft, sending data and commands up there, then you're starting about $2.5 grand per month. and then diagnostics, a little bit more expensive, right? But that's kind of a real big hammer when you're using the diagnostics. Okay, guys?
The intention is to ultimately have this as the main form of control software.
Yes.
In my experience for complex systems, GUI usually is good for maybe 90% of what you need to do,
Yeah.
but if you want to go to that extra 10%, you need to get into the text files.
Yeah.
And, so are you planning this to be side by side with the current technologies, or
What we're doing.
over?
Yeah, it's an excellent question, because that ties into part of the problem. Right now, you have different software, right? You've got situational awareness, command and control of the dish, command macro construction, right? So you're controlling the dish and you're controlling the satellite, and these are 3 different pieces of software, right? We're integrating everything into one, and we're not quite there yet, as you can see from the demo. It's heavy on the graphics. The data-driven part is being put in right now for the command and macro construction. So yeah, the short answer is yes, and the way it's going to work is you're going to click on a subsystem or a part, and it's going to list out all the telemetry there. Everything is going to be there. And when an alert comes up, it's going to show you the telemetry that it thinks you need, but you got total control for drill down personally. The thing is, the video game industry does exactly what you're talking about. They're very competitive at it. If they're bad at it, they don't make money at all. So in our lab, we've actually hired video game engineers, sit them next to a space engineer, sit them next to a software engineer, and we experiment and say, okay, how does this information, how do you represent it graphically? And what if they want to actually see the number? What is that going to look like? They click on it, number comes up, okay? What we need next is, and this is part of the reason why we're starting to sell academic licenses now, is we need feedback from customers. And you need to use it and try it and say, that doesn't work, but that does. Give me more of that. And then it'll evolve, right? And that's what we want to have happen. Because that's the only way you're going to be able to go from this junk on a screen. And you can actually see it. This is different software suite than this. They got 4 different software suites. And you're looking at like screens. You need 3 different screens to do anything for 20 different people. So a massive problem you're talking about. Absolutely massive.
Because sometimes going graphical is a hindrance, and for some things it's easier not to go graphical.
Like what? What things are easier without graphics?
I'm just thinking, generally speaking, you know, the engineers, if you're, for example, if you have to use a Windows-based system,
Yeah.
where you have to click on everything,
Yeah.
for some engineers it is easier to go in and type in 2 commands and it does everything automatically for you
Okay.
on a text file.
Okay. On the back end, because we are finding that I get mixed responses to this, because the younger generation doesn't want to deal with that. The older generation does want to deal with it. Although we are seeing some of the big players get mandated to make their equipment more graphical video game use because they're retiring, right? What we have is we've made a bunch of scripts very easy to use. So if you're the type of person who doesn't want to see the TLE on the screen in text on the screen, you want to actually go into the script and change it manually, you can. We've also put in the text-based stuff as a separate screen that pops up. And it's not in the demo, it's on the actual version we're going to sell. And that took a lot of work. I was like,
So
oh,
it's
that's
there in
work.
the background.
Absolutely, absolutely it's there.
Are you going to end up doing an API? So you've
Yes.
just got, okay.
Yes, so you can modify your own, and we have to because our competitors are doing it. So you know, you'll be able to make your own APIs and do your own business on the Piggy, and that'll be great too. You had a question over here?
Sorry, it was exact same question.
Exact same
So it's like Python
question,
API or something.
Actually, I might call it stop the questions.
Okay, guys, thank you very much.
Thank you, Jason.